Private satellite companies, past, present, and future. Introduction. The realm of private satellite companies has experienced remarkable transformation over the past few decades, transitioning from early experimental endeavors to a dynamic and competitive sector driving innovation and commercialization in space. This report provides a comprehensive overview of the evolution of private satellite companies, highlighting key developments from their inception to the present day while also exploring future trends and possibilities. Past, early developments. 1. Origins of private spaceflight. The journey of private satellite companies began in the late 20th century, with Orbital Sciences Corporation, founded in 1982, being a pivotal player during this era. The company made history in 1990 with the launch of the Pegasus, the first privately developed space launch vehicle, marking a significant milestone in commercial spaceflight. The successful launch of Pegasus demonstrated that private companies could undertake space missions traditionally dominated by governmental agencies. 2. Growth and mergers. Throughout the 1990s and early 2000s, Orbital Sciences Corporation expanded its capabilities through strategic mergers and acquisitions. In 2014, it merged with Alliant Tech Systems to form Orbital ATK, which broadened its service offerings, including the development of the Antares rocket and the Cygnus spacecraft for NASA's Commercial Resupply Services (CRS) to the International Space Station (ISS). Present, a new era of commercial spaceflight. 1. Dominant companies. The present landscape of private satellite companies is characterized by several key players that have revolutionized the industry. SpaceX. Founded by Elon Musk in 2002, SpaceX has become a leader in the space industry with its Falcon 1, Falcon 9, and Falcon Heavy rockets. The company is renowned for its innovative reusable rocket technology, which has significantly reduced launch costs. SpaceX's Dragon spacecraft, operational since 2010, is utilized for ISS resupply missions and crew transportation. Blue Origin. Established by Jeff Bezos in 2000, Blue Origin focuses on both suborbital and orbital flight. Its New Shepard rocket is designed for suborbital tourism, while the New Glenn rocket aims to provide reliable access to orbit. Blue Origin is also collaborating with Sierra Space on the Orbital Reef project, a commercial space station set to be operational by 2027. Sierra Space. A spin-off from Sierra Nevada Corporation, in 2021, Sierra Space is developing the Dream Chaser spaceplane, which has been selected for cargo missions to the ISS under NASA's CRS program. The company is also working on habitat systems for low Earth orbit (LEO). Rocket Lab. Founded in 2006. Rocket Lab specializes in small satellite launch services through its Electron rocket. The company caters to the growing demand for dedicated missions for small payloads, positioning itself as a key player in the small satellite launch market. 2. Trends and innovations. The present era is marked by a focus on reusability, collaboration, and the pursuit of new markets. Emphasis on reusability. Companies like SpaceX and Blue Origin are at the forefront of reusability with the aim of making spaceflight more sustainable and cost-effective. Collaborative ventures. Partnerships such as that between Blue Origin and Sierra Space for the Orbital Reef illustrate a growing trend toward collaboration in developing large-scale projects like commercial space stations. Technological advancements. The use of 3D printing and innovative manufacturing techniques is being explored by companies like Relativity Space, which aims to streamline rocket production and reduce costs. Future, expanding horizons. 1. Vision for commercial spaceflight. The future of private satellite companies appears promising, with several ambitious projects on the horizon. Key initiatives include Orbital Reef. Developed in partnership with Blue Origin, this mixed-use space station is slated to support research, commerce, and tourism in LEO by the end of the decade. Dream Chaser. Sierra Space's Dream Chaser is anticipated to commence cargo missions to the ISS shortly, with aspirations to expand its capabilities for commercial spaceflight. Emerging competitors, new players like Firefly Aerospace and Relativity Space are entering the market, focusing on innovative rocket designs and manufacturing methods to meet the evolving demands of satellite deployment. 2. Challenges and opportunities. While the future is bright, challenges remain. The landscape is competitive and companies will need to navigate regulatory hurdles, secure funding, and demonstrate reliability to gain market share. However, the increasing global demand for satellite services, from communications to Earth observation, presents significant opportunities for growth. Common themes and differences. 1. Key points. Across the examined companies, several common themes emerge. Focus on reusability. The drive toward reusability is a unifying goal as companies seek to make space access more sustainable and cost-effective. Collaborative efforts. Partnerships between companies are becoming increasingly crucial for developing large-scale projects, indicating a shift toward collaborative rather than competitive strategies. 2. Differences in focus. Differences exist primarily in the focus areas of these companies. Launch services versus habitat development. SpaceX and Blue Origin emphasize launch services and satellite deployment, while Sierra Space focuses on transportation and habitat technologies. Market segments. Companies like Rocket Lab are catering specifically to the small satellite market, while others are targeting broader commercial and governmental contracts. Timeline of key events. Below is a timeline highlighting significant milestones in the evolution of private satellite companies. 1982, Orbital Sciences Corporation is founded. 1990, Pegasus, the first privately developed launch vehicle, is launched. 2002, SpaceX is founded. 2010, SpaceX's Dragon spacecraft completes its first cargo mission to the ISS. 2014, Orbital Sciences merges with Alliant Tech Systems to form Orbital ATK. 2021, Sierra Space is established as a spin-off from Sierra Nevada Corporation. 2022, Blue Origin and Sierra Space announce plans for the Orbital Reef project. 2024, Dream Chaser's first flight is anticipated alongside significant advancements from various companies in space technology. Conclusion. The evolution of private satellite companies reflects a dynamic interplay of innovation, collaboration, and ambition. From the early days of Orbital Sciences Corporation to the present dominance of SpaceX and the emergence of new players, the sector has undergone a profound transformation. As we look to the future, the possibilities for commercial spaceflight and satellite deployment are vast, with opportunities for growth and exploration in an increasingly interconnected world. The journey is far from over, and it promises to be a thrilling one as humanity ventures further into the cosmos. Counterintuitive information in private satellite companies, past, present, future. 1. Early private spaceflight versus current dominance. While the narrative often emphasizes the rapid rise of companies like SpaceX and Blue Origin, it can be surprising that the first significant private space company, Orbital Sciences Corporation, was founded in 1982 and achieved milestones in the late 20th century. This suggests that the groundwork for private spaceflight was laid much earlier than many assume. And it was a slow burn before companies like SpaceX revolutionized the industry. 2. Mergers and acquisitions as growth drivers. The history of private satellite companies often highlights startups that grow rapidly. However, the growth of companies like Orbital ATK, formed from the merger of Orbital Sciences Corporation and Alliant Tech Systems, demonstrates that mergers and acquisitions are vital for expansion and diversification. This contradicts the typical startup narrative of organic growth. 3. Public versus private funding. Many believe that private companies like SpaceX and Blue Origin are entirely funded by private capital and venture investments. However, a significant portion of their contracts and funding comes from government sources, including NASA contracts for resupply missions to the ISS. This reality challenges the perception of private companies as entirely independent from government support. For reusability's role in cost reduction, the success of reusable rocket technology credited primarily to SpaceX. leads to the assumption that all future launches will be economically viable. However, the complexity and costs associated with developing and maintaining reusable systems can actually lead to higher initial investments, which may not yield immediate cost benefits compared to traditional expendable launch systems, potentially skewing economic models in the short term. 5. Sierra Space's future ambitions versus current challenges. Despite Sierra Space's ambitious plans for the Dream Chaser and the Orbital Reef, recent layoffs and restructuring indicate that the road to achieving these goals is fraught with challenges. This juxtaposition raises questions about the sustainability of their business model and the reliability of ambitious projections in the commercial space sector. 6. Global market dynamics. While the focus is often on American companies, private satellite markets are burgeoning globally with significant contributions from countries like India, China, and several European nations. This challenges the notion that the private satellite industry is predominantly an American phenomenon, indicating a more competitive and diverse global landscape than is often portrayed. 7. Small satellites and launch capacity. The perception that larger rockets are necessary for satellite launches overlooks the growing segment of small satellite launch providers like Rocket Lab and Firefly Aerospace. These companies have carved out a niche that demonstrates that smaller dedicated launch vehicles can be economically viable, countering the belief that only large payloads can sustain profitable launches. 8. Market saturation versus demand. There is a prevailing belief that the satellite launch market is oversaturated due to the influx of new companies. However, increasing global demand for satellite services, e.g., internet from space, Earth observation, etc., suggests that there is substantial room for growth, challenging the assumption that more providers will lead to reduced profitability for all. 9. Partnerships as a trend. The narrative often emphasizes competition among private satellite companies, but the increasing trend of collaboration, such as between Blue Origin and Sierra Space, highlights a counterintuitive aspect of the industry where companies pool resources for mutual benefit rather than compete directly. This collaborative spirit can lead to faster technological advancements and shared risk. 10. Public perception versus reality of space tourism. The idea that space tourism is just around the corner, ready to be mass-marketed, contrasts sharply with the reality of ongoing technological, regulatory, and safety challenges faced by companies venturing into this space, such as Virgin Galactic. The public excitement may not align with the practical realities of commercial space travel, which could slow the pace of actual tourism offerings. These counterintuitive points illustrate that the private satellite industry is not only complex but also shaped by historical precedents, collaborative efforts, and market dynamics that challenge conventional wisdom about competition, funding, and the future of space exploration. In the evolving landscape of private satellite companies, several key insights may be overlooked by the general public, particularly regarding the implications of technological advancements, the dynamics of market competition, and the collaborative nature of future space endeavors. 1. Reusability as a game changer. One notable aspect often underappreciated is the monumental impact of reusability in launch vehicles. Companies like SpaceX and Blue Origin have pioneered reusable rocket technology, which has drastically reduced the cost of access to space. SpaceX's Falcon 9, now routinely reused for missions, exemplifies this shift. This innovation not only makes satellite launches more affordable but also significantly enhances launch frequency and reliability. The significance of this development cannot be overstated. It democratizes access to space for smaller companies and nations, enabling a broader range of satellite missions from scientific research to commercial applications. As launch costs decline, we can expect an explosion in satellite deployment, which will enrich data availability and foster global connectivity. 2. The role of strategic partnerships. The trend towards collaboration among private space companies is another critical but often overlooked point. For instance, the partnership between Sierra Space and Blue Origin to develop the Orbital Reef commercial space station highlights a shift from competition to cooperation in the industry. This collaboration is significant because it combines expertise from both companies, potentially accelerating the development process and spreading financial risk.
Such partnerships indicate a maturation of the space industry,
where companies recognize that pooling resources and knowledge can lead to more ambitious projects that would be challenging to undertake independently. The future of space exploration and commercialization likely hinges on these strategic alliances, which can facilitate groundbreaking innovations and projects.
3. Evolving market dynamics.
The changing competitive landscape is another aspect that deserves more attention.
Traditional aerospace companies are now competing with nimble startups, which are often more innovative and quicker to adapt.
Companies like Rocket Lab and Relativity Space highlight the emergence of a diverse array of players in the satellite launch market, each bringing unique technologies and approaches. This diversification can lead to increased competition, which typically drives innovation and lowers prices.
However, it also raises questions about market saturation and the long-term viability of some startups. Understanding these dynamics is crucial for stakeholders in the industry, as it will shape the future of satellite technology services.
And accessibility. 4. Technological innovations beyond launch vehicles. While the focus is often on launch vehicles, the advancements in satellite technology itself are equally significant. The development of smaller, more efficient satellites such as CubeSats has opened up new avenues for research and commercial applications. These smaller satellites are not only cheaper to build and launch, but they also have the potential to work in swarms, providing enhanced capabilities for Earth observation, telecommunications, and scientific research.
Moreover, innovations in satellite propulsion systems such as electric propulsion
are setting the stage for longer missions and greater operational flexibility in orbit. This aspect of satellite technology development often receives less attention, but is vital for long-term space missions and the sustainability of satellite constellations.
5. The impact of regulatory environments. The regulatory landscape surrounding satellite launches and operations is another critical area that can be overlooked.
As the number of private satellite companies increases, so too does the need for clear and effective regulations to manage space traffic, ensure safety, and address issues like space debris. The establishment of regulatory frameworks that balance innovation with safety and sustainability is essential for the long-term viability of the space industry. Stakeholders must recognize the importance of engaging with regulatory bodies to shape policies that will enable new technologies while safeguarding the orbital environment.
6. Global implications of private space ventures. Finally,
the implications of the rise of private satellite companies extend beyond national borders. As these companies expand their operations, they will increasingly play a role in global communications, environmental monitoring, and disaster response. The ability of small and medium-sized countries to leverage private satellite services can enhance their autonomy in data collection and analysis. This democratization of space capabilities can lead to improved disaster response mechanisms and contribute to global efforts in climate monitoring and research.
Conclusion.
In summary, the evolution of private satellite companies is marked by significant trends in technology collaboration, competition, and regulatory response. These elements shape not only the future of the space industry but also the broader implications for society, the economy,
and international relations.
Recognizing and understanding these nuanced aspects will be crucial for stakeholders looking to navigate the complexities of this rapidly advancing field. Here are 4 valuable points for in-depth analysis and discussion regarding private satellite companies, reflecting on their past, present, and future.
1. Evolution of technology and market dynamics. The progression of technology in the satellite industry has been remarkable, particularly with the introduction of reusable launch systems. Companies like SpaceX have pioneered this shift, enabling significant cost reductions in satellite launches.
The evolution from the early days of private spaceflight, represented by Orbital Sciences Corporation's Pegasus launch vehicle, to the current capabilities of Falcon 9 and Falcon Heavy rockets, illustrates the rapid advancement and increasing accessibility of space technology. Analyzing how these technological advancements have influenced market dynamics, including competition, pricing strategies, and entry barriers for new players,
can provide insights into the future direction of the industry. 2. Collaborative ventures and industry partnerships. The trend of collaboration among private satellite companies is increasingly evident, as seen in initiatives like the joint development of the Orbital Reef space station by Blue Origin and Sierra Space.
This shift towards partnerships reflects a strategic approach to share resources and expertise in tackling complex projects which often require significant capital investment and technological innovation. Discussing the implications of these collaborations on innovation, operational efficiencies, and market competitiveness can lead to a deeper understanding of the industry's collaborative landscape and its potential impact on future space exploration and commercialization efforts. 3. The role of government contracts and support.
Government contracts have played a crucial role in the growth of private satellite companies. NASA's Commercial Resupply Services (CRS) program, for example, has provided vital funding and opportunities for companies like Orbital ATK, now part of Northrop Grumman, and SpaceX to develop their capabilities. Analyzing the dependency of these companies on government contracts and the implications of potential policy changes or shifts in government funding priorities will shed light on the sustainability and future growth prospects of private satellite firms. This includes examining how these companies can diversify their revenue streams beyond government contracts to remain competitive. 4. Future prospects, commercial space economy, and beyond. The future of private satellite companies is closely tied to the growth of a commercial space economy, which includes emerging sectors such as space tourism, in-orbit manufacturing, and resource utilization from asteroids or the Moon.
Projects like Sierra Space's Dream Chaser and the anticipated Orbital Reef space station indicate a growing emphasis on creating sustainable habitats in low Earth orbit (LEO) that can support various commercial activities. Discussing the potential for these developments to revolutionize access to space, stimulate economic growth, and foster international collaboration will provide a comprehensive view of what lies ahead for the private satellite industry. Additionally, it will be essential to consider the challenges and regulatory frameworks that will shape this burgeoning sector. These points serve as a foundation for further exploration and discussion of the complexities and future trajectories of private satellite companies in the context of an evolving space landscape. Famous historical cases of private satellite companies. 1. Orbital Sciences Corporation (OSC).
Founded in 1982. Orbital Sciences Corporation was one of the early pioneers in commercial spaceflight.
The company achieved several historic milestones, including the launch of the Pegasus rocket in 1990, which was the first privately developed space launch vehicle. OSC's development of the Antares rocket and Cygnus spacecraft for NASA's Commercial Resupply Services (CRS) to the International Space Station marked significant advancements in public-private partnerships in space exploration. In 2014, OSC merged with Alliant Tech Systems to form Orbital ATK, which later became part of Northrop Grumman. The evolution of OSC reflects the growing capabilities and roles of private companies in the space industry. 2. SpaceX. Founded in 2002 by Elon Musk, SpaceX has revolutionized the aerospace industry with its innovative approach to space transportation. The company's Falcon 1, Falcon 9, and Falcon Heavy rockets have demonstrated the viability of reusable rocket technology, significantly reducing the cost of access to space. SpaceX's Dragon spacecraft was the first commercial spacecraft to reach the International Space Station in 2012. The company's ambitious plans for the Starship program aim to make interplanetary travel feasible, showcasing the potential for private companies to lead in the future of space exploration. 3. Blue Origin. Established in 2000 by Jeff Bezos, Blue Origin has focused on developing suborbital and orbital spaceflight capabilities. The company's New Shepard rocket successfully completed its first crewed flight in July 2021, marking a significant milestone in commercial space tourism.
Blue Origin is also developing the New Glenn rocket and has partnered with Sierra Space to create the Orbital Reef space station, a mixed-use habitat for research, commerce,
and tourism in low Earth orbit.
Blue Origin's developments illustrate the private sector's increasing involvement in space infrastructure and exploration.
These cases illustrate the significant impact that private companies have had on the space industry, driving innovation, collaboration, and new commercial opportunities in satellite and spaceflight technologies.
Future outlook: predictions for private satellite companies. The landscape of private satellite companies has transformed dramatically over the past few decades, and their future holds even more potential for innovation, expansion, and commercialization.
This analysis provides a forward-looking perspective on the trends and developments that are expected to shape the future of private satellite companies in the coming years.
1. Increased demand for satellite services. The demand for satellite services is projected to grow significantly due to several factors.
Global connectivity needs. As the world becomes increasingly connected, the demand for broadband internet, particularly in remote areas,
will drive the growth of satellite communication services. Companies like SpaceX with its Starlink project and Amazon's Project Kuiper aim to provide global internet coverage through large constellations of low Earth orbit LEO satellites. Earth observation and data analytics. The need for high-resolution Earth observation data for applications in agriculture, climate monitoring, disaster recovery, and urban planning will continue to rise. Companies like Planet Labs and Maxar Technologies are already leading in this space, and their services will likely diversify and expand. 2. Technological advancements.
The future will see rapid advancements in satellite technology, including
miniaturization and cost reduction. The trend towards smaller, more affordable satellites, CubeSats and SmallSats, will enable more players to enter the market, fostering innovation and competition. The ability to launch multiple satellites in a single mission will further reduce costs and increase accessibility.
Enhanced reusability. Companies like SpaceX have set the standard for reusability in orbital launches, and this trend is expected to continue, with other players adopting similar technologies. The development of reusable rockets and spacecraft will drastically lower the cost of access to space.
AI and autonomous operations. The integration of artificial intelligence AI in satellite operations, from launch to data processing, will enhance efficiency and reduce operational costs. Autonomous satellites could perform tasks such as orbit adjustments, data collection, and anomaly detection without human intervention. 3. Expansion into new markets.
Private satellite companies are likely to explore new markets and applications.
Space tourism. With the success of companies like Blue Origin and Virgin Galactic in suborbital space tourism, the market for commercial space travel is expected to grow. This could create demand for satellite services to support operations and logistics. In-orbit manufacturing and resource utilization. The concept of in-orbit manufacturing, where satellites produce components in space, could become viable.
Companies are also investigating the potential for space mining, targeting asteroids and the moon for valuable resources.
Commercial space stations. Initiatives like Blue Origin's Orbital Reef and Axiom Space's plans for commercial space stations could lead to new business models that integrate satellite services with research, manufacturing, and tourism.
4. Global collaboration and regulation.
The future of private satellite companies will also be influenced by international collaboration and regulatory frameworks.
Public-private partnerships. Governments around the world will increasingly collaborate with private companies for satellite technology, space exploration, and national security initiatives.
Such partnerships can provide funding, infrastructure,
and support for innovative projects. Regulatory frameworks. As satellite constellations proliferate, the need for comprehensive regulatory frameworks to manage space traffic, orbital debris, and spectrum allocation will grow.
The establishment of international norms and regulations will be crucial in ensuring sustainable space operations. 5. Challenges and considerations. Despite the promising outlook, private satellite companies will face several challenges. Space debris management. The increasing number of satellites in orbit raises concerns about space debris. Companies will need to invest in technologies and protocols for debris mitigation and end-of-life satellite disposal.
Market saturation and competition. As more companies enter the satellite market, competition will intensify. Companies must differentiate their offerings and demonstrate unique value propositions to maintain market share.
Technological risks. Rapid technological advancements come with risks, including potential failures in new systems and technologies. Companies will need robust testing and validation processes to ensure reliability and safety. Conclusion. The future of private satellite companies is set to be characterized by significant growth, technological innovation, and an expanding range of applications. The interplay of increased demand, technological advancements, and new market opportunities will drive the evolution of the industry. However, challenges such as space debris management, regulatory frameworks, and competitive pressures will require careful navigation.
As these companies continue to innovate and adapt, they will play a pivotal role in shaping the future of space exploration and utilization.